mentioned either in ultimate strength or yield strength is our principal stresses. The other value is equal to what? 0. No point reporting. Okay. So this is how we get the data. And then lastly, for shear, what do we see? So for shearing test, we have a structure. So now we go through a torsion. Okay, T and T prime, not T1. Okay, T and T prime. So now what do we see? Okay, so in terms of stresses, okay, so the shear stress will go in this direction. Okay, that is our shear stress direction. And then if I do the hidden detail, okay, we have shear stress over that direction, and then you have shear stress going in this direction. Okay, so for this case, we know that our shear stress, okay, and now I have to consider whether x, so if this is my transformation, okay, y, so we know that the intersecting plane is on the x, so this is shear x y, this is shear y x. Okay, so this is our point x, the other side is our point y, and the front surface is our point z. So now we can construct another mole circle now. Okay, so that is our normal stress, and this is our shearing stress. Okay, so this is our normal stress, shearing stress element rotate clockwise, rotate anti-clockwise. So we know point x, y, and z, the normal stress are on the center line, stress y and stress z. Okay, and then if we were to look at the rotation of the element, x is doing a anti-clockwise direction, so this is our point x. Over here, this is our point y, and then from here we draw another circle. Okay, so what we tend to report when we do shearing stress is we will report the what? We will report the tau max. Okay, we'll report the tau max. So what you will see, if we go back to the material handbook, all right, you will see that not a lot of material properties are reported in tension and also reported in shear. Okay. Now, some of you might ask me, Eugene, what if, like over here, the 345, 450, 345, and 690, we don't have the shear value? What can we do? Okay. So in probably week 10, I'll show you how to estimate based on the yield criteria. Okay. So now you can see, right, how from material handbook, right, we can find that the material handbook is reporting on the principal stresses. That is why it's critical for us, okay, in our structure to also determine what? Principal stress. At the end of the day, we want to determine what? The principal stresses. Then we can compare with our material handbook, because This principal stress that you calculate over here is based on a non-uniaxial direction loading condition. And then you compare with the unidirectional loading condition, the principal stress. The common thing is this: in principal stress, at the principal stress location, the shearing stress is equal to what? 0. That is the only common thing. Okay, right. So we are going to, so for today, we are going to do the first stage, okay, which sometimes can be the most confusing. Okay, where student will have a lot of problem is to determine what is the axial force, what is a bending moment, what is a torque, and what is the shearing force. Okay, if you don't determine this value, you can forget about your analysis. Okay, the normal stress is easy. Okay, the shearing stress that you see over here is not straightforward, because sometimes there is thin wall and non what? Thin wall. Okay, so you have to determine the stresses with thin, or sometimes when is it a non-thin wall. The stress field changes a lot when it's thin wall and non-thin wall. Okay, right. So let's do how to determine. Okay. Okay, determination of axial force, bending moment, shearing force, and torque. Okay, so we're going to look into this example. Okay, and I'm going to devise a method, okay, that I've developed over the years that will help you, okay, determine what are the bending moment, what are the shearing force, what are the torque, and what are the axial forces easily. Okay, and this is not taught in the textbook, or this is from years of experience by doing a lot of examples. Okay, and when I use this method, I will never get it wrong. Okay, if I use moment vectors, okay, I sometimes can get it wrong. Okay, so use this method. Okay, I will strongly recommend you. I am starting to confuse. How Po? What are you starting to confuse about? Can you ask me, please? You okay? Or you're just making a comment? So I don't hear from you. Oh, about the table. So as I said, I'm going to teach you how to find out what is the what is the axial force, what is the bending moment, what is the shearing force, what is the torque. Okay. So for this case, we are going to identify or calculate the stresses acting on element H and element K. Okay. So step number one, the first thing I want you to do, okay, step number one is to identify the neutral axis okay of element H and K. Okay. So what do I mean by that? So we know that this is your element H and K. The neutral axis, okay, of the just element H and K is down here. It is now just drawn, right? This is our neutral axis for element H and element K. Okay. Then step number 2. Later on, I'll draw step number 2 for you. You'll be more clear. Okay. Do not analyze the dots, okay, and process. Okay. And don't worry about step number 2. I will explain later on what do I mean by that. Okay. So more important thing, whenever you see a structure like that, you need to know where your transformation is. So we have our X. We know that this is our Y, and this is our Z. Okay. So the first thing, so remember, it is a 3D problem. I'm solving on a piece of paper. Paper is 2D, right? You only can write in X and Y axis only, right? So we're going to transform this 3D problem into a 2D analysis. Okay, what do I mean by that? So the first thing of all, the first thing that we're going to do, we're going to view the structure in different plane. Okay, so the first plane that we're going to view is we're going to view this in this direction. So this is my transformation, right? And this is our X, and this is our Y, and over here, this is rotation about Z. Okay, so we're going to view that the structure in 2D now. Okay, and then from there, we're going to sketch. Okay, so we're going to sketch. So we know that we're going to sketch this now. Okay, so this is, as I said, this is just a sketch. So we know that this is 2, 4, 6. So this is our sketch. Okay, then we have 6, 4, 4. Okay, so this is our structure. And then the next thing that we do is we're going to sketch where our elements are. So this will be our element H, and this will be our element K. Okay, and then from here you draw your neutral axis. Okay, the neutral axis is relative to element H and K. So this is our neutral axis. Okay, then we put in our forces. So that is our 50 pounds cross, right? Because it's going in, so this is our 50 pounds. And then we have somewhere about here, this is our 150 pounds. Okay, then you have another force coming in this direction. This is 150 pounds, right? And then we have a force coming towards us. there is 200 pounds. Okay, so that's all we have.